Hi, how's it going? Welcome to Code with Z. Today's question is LeetCode number 19. Remove the nth node from the end of a list. Now I'll explain and visualize everything in the coming slides, but for the sake of reading the question, let's see what the question is actually asking us for. So here we're actually given the head of a linked list, and we gotta remove the nth node from the end of our linked list. Meaning, if this is our linked list, as you can see, it's represented here as well. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And if our n is 2, we're gonna remove this node here. Why this node? Well, you see, if our n was actually 1, we would have removed the last node. So when it is 2, we're gonna remove 1 to the last, and so on and so forth. And then at the end, after we've removed our node, we're gonna return our answer. Alrighty, let's solve this together, and don't worry, I'll visualize everything so I make sure you fully understand how to solve this problem once and for all. So this is our linked list, and we gotta remove this node here. And we're also given a variable called n, and this is equal to 2. So because our n is equal to 2, we gotta remove the node that has the position of 1 to the last. If this was 1, we would have actually removed the last one, and if this was 3, we would have removed the node that had the position of 2 to the last. And when we say we gotta remove a node from a linked list, in reality, we don't do any modification to the node itself. We actually change the node before it. But as you heard, we use the word node a lot, and a node is just a data structure that has two properties. One is value and the other one is next. And here, for solving this problem, we actually care about the next one here. As you can see, each one of these is a node, and they all have the property of value and the property of next. And this next is the arrow that you see here. We're basically saying the next of this node is this node here. So this arrow is representing the next property. And when we want to remove something from a linked list, the only thing that we need to do is that we're going to remove it from the chain of the nexts. Meaning, we don't want anything to be pointing to this node here. If nothing is pointing to it, that means it's basically removed. So we basically want to do something like this. We're saying, instead of pointing to this 4 here, point to this 5. So we're actually making modification to the node we have here. If this node doesn't point to this 4 here, it's like it never existed, because this node here will no longer be a part of this chain that we see here. So how we actually go from this to this? Well, we only need 3 simple things. I'll show you all 3 and then I'll tell you how it's gonna work and I'll visualize it for you. So the first thing that we need is another node, and we're gonna call it dummy node. So this is just a node that we defined. These nodes here were given to us by the question, and we defined this one ourselves. And as you all know, each node has a next, right? So currently the next of this node is pointing to nowhere, right? It's not linked to anything. And we want to link it to the head of our linked list that was given to us. And the head is basically the first node in our linked list. As you can see, this one here is our head. So let's actually do that. Now our dummy node is connected to our linked list. And you're gonna see why we need this, because I'll visualize everything and it's gonna be really clear. But after we've actually defined this and we've linked it to our linked list, we're gonna need 2 more things: a left pointer and a right pointer. And this is everything we need. So now let's visualize it. So our left pointer is gonna be initialized to the position of our dummy node. So we first define our dummy node, we link it to our linked list, and then our left pointer is gonna be pointing to the position of our dummy node. And our right pointer is gonna be pointing to the position of the head of our linked list, meaning the first node in the linked list that was given to us by the question. So let's do that. As you can see, our left pointer is pointing to this D or dummy node, and our right pointer here is pointing to the head of our linked list that was originally given to us. Now, the reason that we need 2 pointers here is because we don't know the position of the node that we want to remove. We know it's 1 to the last, but we don't know where the last is. So we have to somehow get to the last node and then be like, oh, this is the last one. So this is the node that's 1 to the last, and we got to remove this one. And as you remember, we said we're not going to make any modification to the node we want to remove. We're going to make the modifications to the node prior to it. So when we reach the last node, we got to be like, oh, this is the last, and this is 1 to the last. So I gotta be careful and make the modifications to the node that comes before the node we want to remove. And for doing this, we're gonna use 2 pointers. This node here, this right pointer, is gonna tell us when we actually reach the end of our linked list. And then our left pointer is gonna be pointing to the node that's prior to the node that we want to remove, and we're going to make modifications to it. How we're going to do that? You see, we got to define the distance between our left pointer and right pointer in a way that when right reaches this nothingness here after this 5, and when we realize this is the end of our linked list, our left pointer should be pointing to this 3 here. So in the ideal scenario, left should be pointing to this one here, and right should be pointing to this null or nothingness here. But how are we going to calculate the correct distance between these two? Well, you see, we were given this n variable here, and we could basically say we want to keep on moving r as long as n is greater than 0, and each time we move r, we're going to decrement n, like so. So we moved r to the right, and n got decremented, and then we're going to move it one more time, and now r is pointing to this 3 here, and our n is 0. So we actually gonna stop moving r. So this is how we started. As you can see, now the distance between left and right is the correct distance. So now that we have the correct position for r and l, we're gonna start looping through our nodes, and we're gonna move one to the next each time until we actually get to a position where r is not pointing to anything, meaning r is pointing to this nothingness or null here. And then we can make the modification for this node here, because we gotta get to the end to realize which node we actually need to remove. And this happens because the question doesn't tell us that we gotta remove the third node or the second node, for example. It tells us that we gotta remove the node that's one to the last. Alrighty, so let's start looping. So L, which is our left pointer, is gonna be pointing to the next of our dummy node, which is gonna be this node here. And our right pointer is gonna be pointing to the next of this node here, which is gonna be this 4 node. So let's do that. So have we actually reached the end, and is right pointing to null or nothingness? Nope. Alrighty, let's keep on moving. Point to the next of this one. So let's do it. And R went from here to this one because this node here is the next of the prior node. Are we actually done, and is right pointing to null? Nope. Alrighty, let's keep on moving. Now our left pointer is pointing to this one here, and our right pointer is pointing to null or nothingness. And then we're gonna be like, oh, so this is the end of our linked list. So this is the last node, and this is one to the last node that we gotta remove. If we only had access to the node prior to this, so we could make the modifications. Well, would you look at that? Our left pointer is pointing to this node here. So now that we have access to this node, we're gonna change it and modify it, and we're gonna say your next should be pointing to the next of the next. So as you can see, the next of this node is the node that we want to remove, and the next of the node that we want to remove is the node that we want. So we're basically saying your next should be the next of the next, like so, and we're basically removing this from the chain, and this is it. So why did we need this dummy node to begin with? Well, the first position of our left pointer in the beginning was our dummy node, and for returning our linked list, we're gonna say return anything that comes after our dummy node. So we're gonna say return dummy.next. And if we do that, we're gonna actually return the correct linked list, like so. Now let's code this in the simplest way possible. Alrighty, let's code this together. So first we're gonna define our dummy node. So we're gonna say dummy node is equal to new list node. And this list node here was given to us by the question itself. And it basically defines a node. So we've actually defined the node of our dummy node. And then we're gonna link our dummy node. So dummy node.next to our linked list that was given to us by the question itself. Then below it, we're gonna define our left pointer. And this is gonna be pointing to our dummy node. And below this, we're gonna define our right pointer, and it's gonna be pointing to the head of our linked list. But as you remember, this is not the right position for our right pointer. Our right pointer should be ahead of our left pointer by the correct distance, so we can later modify the node prior to the node that we wanna delete. So for doing that, we said we're gonna move right to the next node until we reach the right distance. And for doing so, we're gonna say while n is greater than 0, and if our right pointer is not null, do the following. So each time we're gonna say right pointer is equal to right pointer dot next. So we're actually moving one node at a time. Then we're gonna decrement n on each round. And as you saw in the slides, this is gonna put right pointer in the correct position for what we wanna do later. So now that our right pointer is in the correct position because of this loop, and our left pointer is pointing to our dummy node, which is also the correct position for our left pointer, we wanna move through our linked list until we reach the node prior to the node that we want to delete. So for doing this, we want to keep on looping until our right pointer reaches nothingness or null. So we're gonna say keep on looping as long as right pointer exists, and inside of this we're gonna say right pointer is gonna be equal to right pointer dot next. So each time we're gonna move on to the next node, and we want to also move our left pointer on each round of our loop. So left pointer is equal to left pointer dot next, and then when we break out of this loop, that means our right pointer has reached the end, meaning it's pointing to null and it doesn't exist, and our left pointer is actually at the node prior to the node that we want to remove. So we want to modify this node here so we actually get rid of this node that we don't want here. And for doing this, we're gonna say left pointer dot next is equal to left pointer dot next dot next, meaning instead of pointing to this 4 here, we want you to point to the node next to it. So skip your own next and actually connect to the next of the next node, and that's gonna be this 5, just like we saw in the slides. And then we're gonna say return dummy node dot next, and that's gonna return 1, 2, 3, 5. Now let's run it, moment of truth. Let's see if we're gonna pass it. Yep, as you can see, all of them are passed. Now let's submit it and see if we're gonna pass it as well. Yep, and we're beating 91% of all of the other submissions. That's awesome. Thanks for watching. Don't forget to like and subscribe and keep on coding.